privilege to introduce Chowdhary Musunuri Garu to you all. Shri Chowdhary Musunuri Garu is currently working as a Senior Director, WWFPGA Solutions, Microchip Technologies Inc. He completed his Masters from Arizona State University during 1994 to 1996. With over 30 years of industry expertise, his professional background encompasses key roles such as Senior Director at Microsemi, Senior Manager at Cisco Systems, and prior experience as a Design Engineer at Terabus Networks and National Semiconductor. With these words of introduction, I request Chowdhary Musunuri Garu to address the gathering.
Well, thank you so much, and good afternoon, all. Yeah. Thanks for inviting us all to the college, and it's a great pleasure to talk about some of our experiences. What I'll do is I'll first talk about my company, our company here, and then maybe talk a little bit more about what we do and what opportunities are there for us here. So I work for a company called Microchip, and So I'll talk a little bit about our company first. So as soon as the presentation comes back up. Okay, so what we do is we are a semiconductor supplier that supplies anything from microcontrollers, microprocessors, analog mixed signal devices, FPGAs, sensor solutions, flash IP solutions, and so on. We are about a $10 billion company, USD, based out of Chandler in Arizona, United States. And we have close to around 23,000 employees worldwide, right? Yeah, so I'll skip that. So we are one of these companies which has been very profitable for the last 20 years. So every quarter for the last 130 quarters, we have been giving the return on investment for our investors. So a very profitable company, and we have been that way, like I said, for the last 20 years. We have global developmental centers all over the world. We have design centers in United States, North America, in Europe, in Asia, and also, of course, in India. So it's a worldwide company. We also have our own manufacturing facilities. So not only do we design, but we also manufacture our own semiconductor devices. So our manufacturing locations are currently in North America, primarily in Arizona and in the West Coast and East Coast of North America, some in Europe, and not yet in India, but hopefully someday we will have some manufacturing facility in India as well. We also have our own test and production facilities, and these are mostly in Thailand and Malaysia regions, our test and facility. So to give you an idea of what we provide, right? In a typical board, if you have a typical electronics board, you will have a microcontroller, microprocessor, FPGAs, or some system on a chip, right? To power this chip, you will need some power management, ICs. You will need clocking solutions, PLLs, clock solutions, and so on. And then to bring inputs into this chip, you will need certain sensors, A2Ds, and so on, right? And then you will have a lot of connectivity, such as storage, optical networking, USB, PCIe, Ethernet, and so on. And then these days encryption and security is very important. That's one of the primary things people are looking for. So that's another security chips are out there. And then to output, you might need IOs and motor control drivers, LED drivers, digital to analog converters, and so on. So as a company, we provide all of these devices for a system solution engineer to use these devices together on a board, right? So we become a one-stop supplier for these guys. Now, the reason I'm showing this is most of these devices, these chips that I'm showing, are designed in India, right? They're manufactured somewhere else, but they're all designed in India. Most of them, not all of them, most of them. So there is a lot of opportunities for engineers that are graduating to be able to participate and be design engineers in all of these areas, right? I'll skip this. But some of the mega trends, what's going on these days, right? 5G is becoming an important thing. When I say 5G, it's the mobile 5G network. Now people are talking about 6G. So 5G communications is becoming a big market for us. Edge computing, mostly around factory automation, industrial IoT, and so on. That's another area where we're investing. Data centers, obviously. And then e-mobility, which is electric vehicles and so on. So battery management and electric vehicles type of things. And then ADAS and autonomous driving. So these are the markets where we are focused in primarily. And obviously we play in industrial, automotive, data center computing, communications, aerospace and defense, and consumer appliance areas. I'll skip this, but coming to India. So in India, we are present in Bangalore, Chennai, and Hyderabad. In Hyderabad, we are in Kokapet. That's where we are. Overall in India, we have about 2,000 employees across all design centers, and we have been growing rapidly. We had close to around 140 engineers every year. New college, interns and new college grads into our company every year. We recruit about 140 engineers. So we are growing pretty rapidly in India, and India actually happens to be the second largest design center in the world for us, right? So we're looking for a lot of talent. Now, this is a complex slide. I don't know if you can see it, but I put together this slide to show you what happens or how complex a semiconductor design and manufacturing is, right? So I'll take a minute to talk about this. So if you look at this, initially there's somebody with an engineering background and an MBA who is coming up with a product marketing document, right? They have done the research in the market. They said, hey, this is a chip we want to build with so and so features, and they come up with a product marketing document. So with that, we build something, we build an architectural specification, an architectural document. And that architectural document goes into more detailed specifications or, design details, right? From that comes, circuit design and ASIC design. So the circuit design, obviously, people need to know how to handle with CMOS circuits or, analog and digital circuits. ASIC design, they need to know how to write an RTL, Verilog, VHDL, whatever, right? From there comes custom layout or standard cell place and route, right? So again, they need to understand how to handle the tools and partition the design and make sure that they're doing the layout properly. In all these things, obviously, we want the chip to come up right the first time. So there's a lot of circuit verification, logic verification, and timing closure that happens. So here people need to, again, understand how to write the right test benches to do proper verification. They need to understand how to do timing closures, right? So they need to know what is setup time, hold time, how to set up the timing constraints and so on. And then once everything is great, we send the chip to fabrication. Obviously, the fabrication currently is done outside India. But once the silicon comes back, somebody has to validate it. So they have to sit in the lab, use oscilloscopes and protocol analyzers to validate this chip that comes back, right? So that a lot of that happens in India, by the way. And then once that is all done, it goes to final production to customers. When it goes to production, they also need to make sure that we have data sheets and application notes and so on. We need to have customer support team. We need to have applications team that are creating applications designs for customers and so on, right? Along with that, let's say there is a microprocessor or a FPGA. You also need to provide customers with tools. Customers are writing software; they need to be able to compile the software in a certain tool. So you need to provide them tools and so on. So we also need C++ engineers that are very good at writing some of these tools and all that. So if you look at this whole thing, there are a lot of opportunities for engineers that are coming out of our colleges. Like the previous presenters have said, this is not easy. It's difficult, but at the same time, there is also a lot of potential to be very successful and make a lot of money in this industry, right? But what we need are people who are committed and interested in doing what they're really learning in the school year, right? So I think that's my last slide. I wanted to keep it short, and I would like to thank you all for the opportunity.